Okay, we are on day 5 of our exponent rules. Today we're going to be talking about the quotient rules of exponents, in other words, division. So we've done all our multiplication, so let's focus in on some division. The first one that we're going to talk about is quotient of powers rule. So if I have a common base, if you notice here, I have a base of A and I have a base of A. So my bases are the same, and I go to divide those. What we do with the exponents is we subtract them. So when we divide common bases, we subtract the exponents. So let's give this a shot. So if you notice, I have x to the fifth divided by x squared. I have a common base, so my base is x to the 5 minus 2, which is x to the third. Now, why does this rule work? Well, x to the fifth means that we have 5 x's multiplied together. X squared means we have 2 x's multiplied together. Now, if you think back to like your pre-algebra, if I gave you a fraction 6/9 and I said to you, simplify it, what we would simply do is we would look for a common factor and we would cancel that out. So for example, 6 can break down into 2 times 3. 9 breaks down into 3 times 3. If you notice, I have a common factor of 3. I would cancel that out and I'd be left with 2/3. Well, the same idea is going on here. So I have 5 x's multiplied in the top, 2 x's in the bottom. So those are common, and that leaves me with x to the third. Now, the reason I like to show this though is if I were to give you a problem like this, if I said x to the fourth over x to the eighth. Now, when you stop to think of that, that means you have 4 x's in the top, you have 8 of them in the bottom. So when I go to start canceling, I can start canceling here and these would cancel. And if you notice, that leaves me with 4 x's, but this time they are all in the bottom, so x to the fourth. Since everything in the numerator canceled, I would put a 1 there. So it would be 1 over x to the fourth. So the way I like to think of this is more, not necessarily as a subtraction, but more of a canceling process. So basically your answer stays where the majority of those variables are. So the common base, wherever it is, that's going to keep the majority of them. Then you just cancel out the ones that are from the other position, whether that's the numerator or denominator, and then you have your answer part. Okay? The second rule we're going to talk about is the power of a quotient rule. So here, if I am raising a division problem to a power, then you multiply each exponent of each term by that exponent. This is very similar to what we did with a power of a power rule. So when we look here, what we're simply going to do is we're going to take this 4 and it goes into everything. So it'd be x to the 2 times 4 over y to the 3 times 4, which would get me x to the 8th over y to the 12th. Since I don't have a common base, that would be what we have then. Now, why does this rule work? Well, if you remember, the exponent of 4 means that I have 4 of that grouping. And if you look, you have 4 of that grouping. So that means for each of those groupings, you have an x times x. And for each of the groupings, you have a y times y times y. And if you take those and add all those up, you're going to end up with 8 x's and 12 y's. Okay? Now, the other one, though, I wanted just to show you before we start into some examples. If I were to give you something like this, 2x over 3y squared, and let's say we square that. Just like with multiplication, this also goes to the coefficients. So on this example, you would have to take it to everything. So it'd be 2 squared x squared, 3 squared y to the 2 times 2, which is 4. So then we would simplify that to say 4x squared over 9y to the 4th. Okay, so the rules apply very similar to what we had with multiplication. All right, so let's try this. So on number 1, if I look at this, I can do it 2 ways. The first way is using the rule. I can say, oh, I have a common base of x, and then I can simply say, I'm going to take and subtract. So x to the 4 minus 2 gives me x to the 2. The other way to think of this, though, is you have 4 x's in the top, you have 2 x's in the bottom, those cancel, and that leaves you 2 x's, and they're all in the top. Okay, number 2, when we look at this problem, we have 6 x's in the top, you have 10 x's in the bottom, and when we go to cancel, that is going to leave you with 4 x's in the bottom, but since we canceled everything from the numerator, we'd have to have that 1 there. All right, now on number 3, when we look at this problem, the first thing we see is we have coefficients now. The coefficients are not part of the base here, but we do need to simplify them if at all possible. So I look and I ask myself, okay, what number goes into 15 and 10? And the answer would be a 5. So 15 divided by 5 turns into a 3. 10 divided by 5 turns into a 2. The next thing I look at is I look at my x's. So I have x to the 5th, meaning I have 5 x's in the top. I have 2 in the bottom. So these two are going to cancel with 2 of the 5 and make that x to the 3rd. So my final answer then would be 3x to the 3rd all over 2. And then number 4 here, we start off and I look at my coefficients. I have a 2 and an 8. 2 goes into 2 once. 2 goes into 8 4 times. I now look at my variables, and I have 3 x's in the top, 6 in the bottom. So those 3 are going to cancel, leaves x to the 3rd in the bottom. So my final answer would be 1 over 4x to the 3rd. Remember to include that 1 because nothing else is in the numerator. So we have to keep that 1 there. Okay, now let's take a look at the second rule that we talked about. So here, I'm going to start off. I see I've got a 2 raising this whole thing. So I'm going to take that to both. So it's going to be x to the 8th over y to the 10th. Remember, this is multiplied. So x to the 8th, y to the 10th. Now, when we look at number 6, if you look at number 6, there is something we should do first. So here's a little note. Always simplify the fraction first. Okay? So always simplify the fraction first if possible before we raise it to the exponent. So when I look at this problem, I see that I have a 1x in the top, I have 4 in the bottom. So that would turn into 3x to the 3rd. So what I have now is I have 2 over 3x to the 3rd, and I'm going to cube it. So now what I'm going to do is I'm going to take this 3, and it goes to each element in that problem. So now what I have is 2 to the 3rd over 3 to the 3rd, x to the 3 times 3, which is 9. So now 2 to the 3rd, that's 8. Remember, that's 2 times 2 times 2. 3 to the 3rd is 27, x to the 9th. Okay, number 7. So here we're going to put it all together now. So the first thing I'm going to do is I'm going to look at my coefficients. Can I simplify anything? And I can. A 4 goes into both 8 and 20. 4 goes into 8 2 times. 4 goes into 20 5 times. Then I look, do I have anything with my x's? I have 4 x's in the bottom. I have 15 in the top, so that's going to leave me x to the 11th. My next one is now I look at the y's. I have 4 y's in the top out of the 8, and that's going to leave me 4 in the bottom. So now, just to rewrite what we have. So what I have now is I have 2 x to the 11th over 5 y to the 4th. And now I'm going to square that. So now what I do is I take the 2, and now I'm going to bring that in to multiply to each of these. So I end up with 2 squared. 11 times 2 is 22. 5 to the second power. Y to the 4 times 2 is 8. So now I just simplify that. 2 to the second is 4. X to the 22 over 25 y to the 8th. And that is